Welcome back. Today we are going to list down all the important integration formulas that we are going to use so often. And in order to validate those formulas, whether they are correct or wrong, we are going to use a very important trick. Now, in the last lecture we have understood that if integration of a function capital Fx is a small fx plus c, then mathematically correct statement would be going the other way around. That is, differentiation of the small fx must be equal to capital Fx. If I break it down in words, that means that if the right hand side of the result is differentiated, then the answer is equal to integrand. Okay, so when you differentiate this term, you'll get the integrand back. We'll try to exercise this important finding when we are writing down the formulas to check the validity. Let's move on to the first important formula in our list. Our first important formula is integral of x to the power n with respect to x. Now we are going to take special care of the power. So I'm going to mark it as red. So it is x to the power n dx integration. And the answer is x to the power of n plus 1 divided by n plus 1 plus some arbitrary constant. So I have marked all the important things in red. All we have to do is identify what is the power of x, and then we can use that value in the final answer. We have to increase the power by 1 and divide it by the same number, like n plus 1. Now this formula we are going to use very often. So let us try to understand what should be the values of n. Here you can see in the denominator that there is n plus 1. What happens if n becomes minus 1? Then obviously we can't use this formula. The denominator will become 0. So obviously n should not be equal to minus 1. So what happens when n is equal to minus 1? Well, then it will become x to the power minus 1, and that is actually 1 by x. So let us see the second formula in our list. That what is the integration of 1 by x dx? The answer is, wait a moment. Here we'll use this idea that whatever is the answer, the differentiation of the answer must be equal to the integrand here. So what function when differentiated gives 1 by x? The answer is ln x plus some arbitrary constant. So when n is equal to minus 1 in the first formula, then we have the second formula that it will be, that is integration of 1 by x dx is actually ln x. Now let us see the application of first formula, because n could be anything. It could be integer, it could be fraction, only that n is not equal to minus 1. Let us see some examples. So what if I have to integrate x dx? Then all we have to do is, what is the power of x? Here you can see that the power of x is actually 1. So we get the value of, what is the value of n in our formula? So here the answer would become x to the power 1 plus 1 upon 1 plus 1 plus some arbitrary constant. So the final result will become x to the power 2 divided by 2 plus c. So when you integrate x with respect to x, the answer is x square by 2. The power increases by 1 and we get a term in the denominator. Let us try to apply this formula in a different example where we have to integrate root over x with respect to x. So again we have to identify what is the power of x here. The power of x here is actually half. So that is the value of n. N is half. So the final answer will become x to the power of half plus 1 divided by half plus 1 plus some constant according to the formula number 1. So our final answer will be x to the power 3 by 2, and in the denominator we have 3 by 2, so 2 will go up, then we'll have 2 by 3 x to the power 3 by 2 plus constant. Isn't that simple? That will be all for this lecture. We'll be coming up with some other important formulas in the next one. See you then.